Looking at the questions for today's document, the first question involved the probability of no winnings when playing a lottery where you have a .005 probability of winning one amount, .002 of another, and .0001 of another. So the probability of winning nothing is 1 minus the probability of winning something, and the probability of winning something is simply the probability of winning one thing. This would be the probability of winning $100 in the case of the specific problem, plus the probability of another winning, this being the winning of $1,000, and another being the probability of winning $10,000. So we add these three together, and that's the probability of winning something. We subtract that from 1, and we get, well, 1 minus this total being 0.521. 1 minus that is 0.99479. So that's the probability of not winning anything on one ticket. Now, if you bought 1,000,000 tickets, then there's a very high probability that you would win each of these prizes multiple times. This one, of course, more often than this one, but this is a 1 out of 100,000 probability. And if you have 1,000,000, well, that's 10 times 100,000. You would expect basically to win this big prize 10 times. Now, you wouldn't necessarily win it 10 times. You might win it 5, you might win it 15, but probably it's going to be fairly close to 10 if you have 1,000,000 tickets. So what's the expected winning from 1,000,000 tickets? Well, you expect that you're going to win the $100, .005 times 1,000,000 times. Well, that's 5,000 times. Again, it might not be 5,000, but it'll probably be more than 4,000 and less than 6,000, and it'll probably be fairly close to 5,000. In any case, your expectation is you're going to win it 5,000 times, maybe a little more, maybe a little less. And if you win it the expected number of times, and when I say the expected number of times, you don't really expect to win it exactly 5,000 times. 4,990, 5,015 would be almost as probable as 5,000. But that's kind of the average that you would expect, the average number of times you would expect to win on a $1,000,000, on a 1,000,000 ticket purchase. Okay, so you would win $100 5,000 times. Well, that would be $500,000. So your expected winnings, the expected number, the number that you might go a little over, a little under, would be $500,000 on $100 hits. Okay, now you have this probability, .0002, of winning $1,000. And .0002 times 1,000,000 is 200. And yeah, I've got dollar signs here on the million, and there is no dollar sign on the million. Okay, excuse the distraction. 200 times you would win $1,000. Well, that'd be worth $200,000. And here you have 1 in 10,000 chance of $1,000,000. That comes out 10 times that you would expect to win $10,000, and that would be worth $100,000. So you have a total value of $800,000 on 1,000,000 tickets, and the actual total you win would be probably a little bit over or a little under $800,000, but probably wouldn't differ drastically from $800,000. Now, you can do the binomial probabilities and work out just, for example, you have a 99% chance of winning between $750,000 and $850,000, or whatever that probability might be. If you put a range on this, we can use the techniques of this course to figure out what the probability that you would actually fall in that range would be. We're not going to do that. We're just going to stick with the idea of expected value. So expected value is $800,000. Now, at 50 cents a ticket, well, you'd be spending $500,000. on 1,000,000 tickets, and you would expect to win $800,000. So your expected net winning is $300,000. And this would be a good investment. There's practically a zero probability. It would be unfathomably unlikely that you would win as little as $500,000. You would almost certainly win, and you would expect to get something close to a net gain of $300,000 at 50 cents a ticket. Now the question is, what is a ticket actually worth? Well, 1,000,000 tickets would get you $800,000. How much is that per ticket? Well, per ticket, that's $800,000 to 1,000,000 ticket. That comes out 80 cents per ticket. You just divide the winning you get by the number of tickets to get the winning per ticket. Okay? And if you bought 10,000,000 tickets, you would expect to win $8 million. Okay? We could do this analysis multiplying by 10 million each time, and every number would become 10 times as great, and we would end up with a total that's 10 times as great. And that still comes out to 80 cents per ticket. The point being that you would expect to win 80 cents per ticket. So you multiply that 80 cents by whatever number of tickets you choose to buy. That would be the expected value of a ticket. Okay, of course, if you're paying for the tickets, then your expected net would be $300,000 on 1,000,000 tickets, and that would be 30 cents per ticket.